Hi, my name is Troels. I'm a chemistry teacher at Gentofte in Denmark. This video is about how to measure light intensity in a video as a function of time. What I would like to do is to make a small scale of the reaction we see on the left, which is a reaction of luminol together with an oxidizing agent. This creates chemiluminescence, and I would like to quantify how this halvation time of the chemiluminescence is as a function of time. This could be a very good exercise in organic chemistry. The problem is that here at our facilities we don't have professional equipment for measuring the light intensity, so I thought it would be interesting to use IT with a built-in camera in your computer or an external camera to measure the light intensity as a function of time. What else you can do is to do this in physics, where you measure the light intensity of a light bulb as a function of the voltage and try to compare these two things. What we need to set up this experiment is you need an external camera, either built-in or an external one. We have an IPEVO here. Then you need a capability to analyze the intensity of your video or of your images, and here we're going to use ImageJ from NIH, the National Institute of Health, which have a really good capabilities and it's free of charge. We also need to be able to convert from .mau to .avi, and just any converter will do, and I've just found one called MPEG Streamclip. And then the last problem we have here in Denmark is that Excel here in Denmark understands dots as 1,000 separators instead of separators, so we need to convert any dots into commas before we put them into Excel. I'll show you how this works. My setup is as I'm shown here. We have the light bulb here, the camera, and a voltage box over here, which I can make sure of. What you want to make sure is that when you make videos that they are short, I would say maximum of 30 seconds, maybe a minute, but the problem is I've seen that ImageJ can handle more than 400 frames, so try to make your movies as short as possible. Well, very good. This shows how we're going to set up. First I'm going to download ImageJ. I'll download it here first. Then I unzip it. Then I drag the folder into applications folder. Important is to have the whole folder, because there are some plugins we're going to need, which is part of this folder. Then I'm going to start ImageJ. We're just going to search for it as you could normally do. Open it. And when this starts, ImageJ, first thing you want to do is go up to Analyze, Set Measurements. Make sure that you have area, min and max, and the integrated density, very important, and the mean value. So now this is ready. Then I'm going to do the experiments. Right now my voltage is at 1.0, and I'm going to dim the lights. Very good. I start the recording. Then I have 1.5. 2.5. 2.9. 4.1. 4.6. This finishes the experiment. Good. I'm going to export this just onto my desktop. This was number 20. I'm opening this one, the converter. Open file. Number 20. And right away go up to File, Export to AVI. Just the same. Meanwhile, I can close the other applications. Very good. Then I find ImageJ. I go into File, import AVI. Going to find the AVI file, open it. 261 frames after about half a minute. This takes some time. Meanwhile, I can find my Excel. I'm going to get a lot of columns of values. The frame number, the area, the mean, the min, the max, the integrated entity, also the raw, then the slice, and I've made this ready for this one. So I'm just going as a text converter, I have just taken any text converter. This is Text Wrangler. You can find any. This is of course only to Denmark if you need to convert dot to commas, but any converter will do. Let's see if it's done. Soon done. I can put in my measurements 1.0, 1.5, 2.5, 2.9, 4.1, 4.6. Good. Then I need to draw a region of interest. I'll just make a circle over here at the light bulb and make it quite big around it, in case there is any light coming around it. Then I go into plugins. I go into stacks, and then I go into measure stack. Good. I do Command A, Command T as for copy. Then I go into my text editor, Command V. Then I'll have to find. I'm looking for all dots, replace it with all commas, replace all. Then I do Command A, Command C, and I go into Excel. And here's nice too, just to make sure that I can see all numbers. Then I want to have the integrated entity, and it's good to have X on the left and Y on the right. Double click here, make sure I can see all numbers, and then I make a graph here in the top corner, holding Shift, and then click in the corner. Then I want to make XY coordinate, and as you can see, this looks quite good already. You can just do this and insert it again up here in the top. So this makes it looks nice. Very good. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's try. Here the average in Denmark is called middel. That's the function. We're just going to mark some numbers where I can see a clear separation here and not taking the light in the middle where it jumps. This is the first one. Then 1.5 is around 9.6 here. .5 is around 200 something. The next one, 2.9, is around 390,000. 4.1. I should look for 889,000. .6 is the last numbers. Very good. Again, I mark these numbers here. Make an XY diagram. Very good. As you can see here, we have tendency for low voltage that the efficiency is not so far, and then we get into over 2.5 that we actually see quite a linear relation. So this opens up for the possibility to discuss the efficiency of a lamp for, say, low voltage and high voltage. And if you continue this graph for higher voltage, you will see that it will flatten out. I think this is a very good exercise, and using the capabilities most people have available on the computer and for free of charge to be able to do this. Of course, now I prepare this and see that the software works. I will try to follow this up with my reaction with Luminol, but I need to get my hands onto Luminol before and do the experiments before I can show the results of this. So this will follow a later movie. Thanks for looking. Hope you can use it.